Hey, what's going on, guys? Today we're going to be going in a little bit more depth on the primitive data types and how to use those and the different versions and so forth. And that's going to be really cool because then we're going to understand one side of the data type spectrum, then the other side, objects, we're going to be getting into throughout this series. And with that, let's get into primitive types. So the ones we've talked about so far are int. I'm pretty sure that's all. And I think we use double too. So you can declare these things really easily. The difference between an int and a double is that the doubles can use a decimal with the value after that. So you can have fractional values inside of a double. There are actually 6 other primitive types we haven't talked about, and they are right here. We got boolean, byte, char, short, int, long, float, and double. Alright, so let's declare each one of these. So a boolean is true or false. And when you give them the values, you just use the value true or you use the value false, but you don't put it in quotes. That's a string. And like we talked about in previous videos, something in strings and something outside of strings are 2 separate things. So these are not the same values. This is a boolean false, and this is a string that happens to say false. So make sure you don't put the quotes. Next, we have byte. So a byte in computer science is a sequence of 8 bits, and a bit can be either 1 or 0. So for example, we could have this. This is an example of a byte, and you don't really have to understand this in order to use this byte data type. It's basically just a really small data type that can store a very small range of numbers. You can also store characters in here. So for example, if you want to store a character such as the letter C, you use single quotes, and then you just put the value of C in there. And how exactly can you store numbers and characters inside of the same data type? Well, the reason that works is because this is all based on the ASCII table. So if you guys haven't seen the ASCII table, let me show you. Okay, so here's the ASCII table. And basically, there's a bunch of stuff that's super overwhelming. But the important thing to look at is this decimal number right here, this column right here, and the actual character right here. So for example, if we wanted a capital C, that would be right here, and it would have the decimal value 67. So the 2 values are kind of interchangeable, meaning the value C and the value 67 are going to be stored exactly the same way in binary, but whether or not it's a C or a 67 just depends on the interpretation of that binary. So the next one is char, and this works the same way. So we could say char C equals, what do we want to give it? Let's give it capital Z. And going back to the ASCII table for a second. So this gives us a pretty good range of characters. You know, we got all the numbers, we got all the capital letters, all the lowercase letters. And this is usually suitable for small English applications. But if you want to start supporting different languages and different types of characters, then you're going to need a bigger list than this. And that's where Unicode comes in. Here is the Unicode list of characters. And you can see it gives us much larger range of characters. So we can do all kinds of different things. So with that, the char data type allows us to store Unicode, which means we could store different language characters inside of this variable. Next one we have here is short. Short is similar to char in that they're both 16-bit, which is double that of byte, but short is used for numbers. So we could put in here 32767, for example. And then that's the highest number available. Or we could use the negative version. We can actually go negative, and then we get 1 extra value there. Don't worry too much about the ranges. Just know that short is for small numbers. Next up, we have int, which, really steps up the game. This is a 32-bit number. So we can put some pretty darn big numbers in here. And note that you don't use commas or periods inside of these numbers. So you don't space them out like this. And if you're not from the US, you don't use dots either. So you wouldn't do something like this. It's not acceptable. You just leave it plain like that. And then lastly, we have long. And this is the same thing as an int. It's just twice the size, 64-bit, meaning you can store bigger numbers in here. So you can see all the ranges here on this table. But usually I don't worry about it. I know that if I use an int, it's going to cover most cases. And then if I know I'm going to be working with something huge, well then I might want to use a long. Alright, so we've covered all the integer categories. And integers and characters are kind of swappable in the sense that the way they're stored in binary can be interpreted as a character or an integer, just depending on the context. But once we get into floating point, that's a little bit different, and that's what we're going to be talking about now. You'll also notice here that I'm getting an error, and the reason that is because when you create a literal value like this, a long, and you want to specify, hey, this is a long, you have to put a capital L right there. So when we hover over this, it says it's out of range for an integer because it thinks we're trying to create an integer. But if we put that L there, it should work. Now, if we're in the situation where we have a really small number and it's not outside of the range of a normal integer, then we don't need to put that L there because it's just going to get converted to a long. So if you just want to be on the safe side, just keep an L on your values. It's clear because when I look at this, I know that, hey, we're trying to create a long value, not an integer, which are two separate things. And this can take some time getting used to if you're new to programming, because in real life, we just think of numbers as like one thing, but there's actually different categories created by these data types. So the next thing we're going to learn about is float, which similarly, we need to end with an F, just like that. And then we have the double version, which works the same way. You just don't need to put anything right here. So the difference between a float and a double is that a double is 64-bit and a float is 32-bit. So what that means is the float can't represent numbers as precisely, meaning if you're really particular on the math and you want to get as precise as possible, you'll want to use a double. And I would argue that there's almost never a case to use float at all. Just use double in all circumstances unless there's a specific reason you need to use a float for something. Usually that'll be the case if you're like super restricted on memory, but you're usually not going to find that when you're programming in Java. Maybe if you're doing something in C, but for Java, double is going to work 99.9% of the time. Now, when you put a decimal point followed by some numbers, but you leave off the F, it just assumes it's a double. So if I tried something like this, where I say 20.5, I'm going to get an error because it's assuming this is a double and it's not going to let us convert. The other way is okay. So if I did double dd equals 20.5f, we're not going to get an error. And there's something important you need to understand here, and that is the float is a smaller container than the double. Think of them as backpacks, right, that you can put stuff in. In this first scenario, we're getting an issue because we're trying to store a giant backpack's worth of stuff in a small backpack float. The other one is not giving us an error because we're trying to store a small backpack's worth of stuff inside of a larger backpack that can store twice as much stuff. So we only get errors when we're trying to store larger things in smaller things. Now, all of these data types can be used within expressions. So let me just put that F back in here so we don't get that error. So for example, I could say double X, and then I could set that equal to dd divided by S, for example. So we can mix the data types inside of expressions. This here is a double, whereas S is a short, and it's not giving us any issues. That's because, like I said, we're storing it in a bigger container, right? The double is a 64-bit container. But if we did something different, such as making this a float, well, hey, now we're getting an issue. Cannot convert from double to float. Now, there is something called typecasting, which will basically force it, but this is going to put us at risk for a loss of information. Meaning, if you're trying to store 2 backpacks worth of stuff into one backpack, you're going to not be able to put it all in there, and you're going to have to leave some of it behind. That's not always going to happen, though, because we might just be storing some really small value inside of this double, and then it's able to fit inside of that float. So what I would recommend, if you want to learn more about these, go through this document here, or just look up primitive types in Java. There's a lot of examples here on how to do casting and so forth. So if you want to get a lot of information, you can go check that out. Or you could just keep watching this series because I'm going to be using these kinds of primitives all throughout. So the main takeaways from this video is if you're just trying to work with literal values, these extra characters are important. F for float, capital L for long, and that when you're going from data type to data type, you can only store smaller things in bigger things without an explicit cast, like right here. Also, all these yellow underlines, those are not errors. It's just saying we created this variable, but we're not using it anywhere in our code.